Hello student, welcome to today's session. So again in continuation with our series in regard to IITJEE 2022. So here I am placing one important session in regard to inorganic chemistry, that too pertaining to boron family, and we will see that how IITJEE people mix the 2-3 things together in terms of bonding, in terms of mechanistic viewpoint. Generally people feel that inorganic cannot be explained by mechanism. We will be seeing it that many of the things can be logically derived for inorganic chemistry as well. So must watch this session, and let's directly go to, as the my style would be, we would be doing the discussion in the form of problem solving. So we shall be discussing two questions in today's session. Both of these are more than one choice question, so you need to be little careful about this. So which of the following compound is or is are not having any proxy linkage or bond in it? So you are being given some compounds of boron, basically these are borates, and you need to identify which among this would not be having any proxy linkage. And second is a sequential type of a reaction where compound K, one of the sodium salt of boron compound K is being given, which is being heated to give you transparent bead which contains L and M compound, and so on. So first let us go into the first question first. We need to identify this. So as regard to the bonding of boron compounds, I always suggested my student to remember it like this, that around boron, because borons, if we simply write its Lewis dot structure, it is 2-3. So valence electrons are 3 in it, and it would look for 3 more electrons to complete its covalency. So boron, around boron, always remember there would be a 3 bonds possibility, because boron is having 3 valence electron and it can join with another 3 of other elements, as a matter of fact. If in case boron is making 4 bonds around it, that is for sure that then the boron would get a negative charge, because the 3 electrons it already had, and these are the cross electron which it might have got from the other element, and these two are the extra electrons, and that is why it is carrying a negative charge. Here its octet get completed. Or other way around is boron can also join with one side double bond, another side single bond. As a matter of fact, in all of the options given in this particular question, they are dealing, here we are dealing with oxygen. So if I would have to write in regard to the oxygen, so boron can join with oxygen in these forms, isn't it? If I would write it once again for you, so it can join it like this: on this side oxygen, on this side oxygen, on this side oxygen, or oxygen, 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 something like this, and then it would get a negative charge here. Or other way around is here the negative charge, or it has joined with somebody oxygen, either would get at the corner negative charge, or it is joined further and here it is double bond. So only the 3 ways in which you can see that boron is going to join with the other entities. So let us do all these questions one by one. So first, this basically all the options given in this problem is pertaining to borates. What are borates? Borates are the compounds in which the anion of boron is with oxygen. So oxygen and boron are there, and they tend to create a anion. Just like in this case, if you break this out, it would become this thing, B3O6 3 negative. Now you have to rearrange it in such a way so that you can identify the bonding aspect into it. So this is for sure there are 3 boron atoms. Always do it this way, that you just would bring each would join with the BOB bond, and now you are going to place 3 oxygen as negative charge. So 1 oxygen here negative, 1 oxygen here negative, and 1 oxygen here negative. So in this, if you would see, another style of question may be asked in the MCQ form in the single integer type, that in this B3O6O3, how many BOB bonds are there? So there are 3 BOB bonds. So this is another style of question. Along with the question which we are discussing, we can always create more questions the way IITJEE could ask in the form of integer type. Now this is again a very important compound of boron, which we call it as borax. And here if I would break it, So this would become Na2 positive plus B4O7 2 negative. So in this particular case, many things can be asked in this particular question. This is quite an important structure. So here again, if you would bring four boron atoms together and just place all these boron at the corner of a tetrahedron, and you are supposed to make BOB bond with all of these. So if I just would make all the BOB bonds like this, and because still till now I just have made two bonds around the boron, and we are supposed to make 3 bonds at least around the boron. So I can place one here, and since there are 2 negative charges, so you can place it here, negative and negative. So as simple as that. So as regard to this particular question, I just would recommend you, because this is quite an important one, borax in a form B4O7, we used to say it at 10 moles of water. This exactly is the primitive prismatic borax. So this is the ore of the boron, and if I just would write Na2B4O7, the simple this is called as borax glass. Along with the main question, we are adding some information base also. And if the moles of the water of hydration in this is 5, then there is a popular compound which popular name which is given to this particular thing is called as jeweler's box. So this particular crystal on falling light actually enlighten, so that is why it gives you sort of the just like a jeweler box. Okay, so this is a common name. One more thing which we shall add here is that Na2B4O7, if I just would hydrolyze it with water, so what I would get is NaOH and H2B4O7. So 2 moles of water are required here, and this is 2 NaOH. So we used to say this borax is a salt of, because this is a strong base and this is a weak acid. This we call it as tetraboric acid. Tetraboric acid. I think in the next problem something is related to this can be asked, would be there. So we will see into it. Salt of weak acid plus strong base. What next thing which I just would want you to remember is, which again can be a question in the paper, that this 10 moles of water in the borax, how these are joined. Actual water of hydration is how many? Single integer type question again. That how many water of hydration are actually there in a crystal of borax. So I just would draw once again that same structure. So borons are at the corners of the tetrahedron. So we just have made this, and now I just would place oxygens. Fair enough. Okay, and this was the negative charge we just have made few minutes back. Now if I just would add one H positive here and one H positive here, so these two would become OH, and along with it, if I just would add one, because if I would say this is OH and here also this is OH, so I just have added one H positive here to neutralize this O negative, one H positive here to neutralize the H positive. Now these two OH negative can join here and would create a negative charge here, and also would join here to create a negative charge here. So this is a way by which you can understand the things in a simpler way. So what basically I did is I just have added 2 water molecules to the species, or if I just would write it once again. So what we did, these are the 3 boron atoms which are joined to each other through oxygen, This is the form, and into this I just have added 2 moles of water. Is it okay? So this basically now would be written as Na2, which is a very popular question, B4O5. How many OH are there? 4. And now you would find that 2 water has gone inside, so this would have 8 water of hydration. This is a very popular single integer type of equation, that in the crystal of a borax, actually how many moles of water act as a water of crystallization. So this is another thing which you should add to your knowledge bank. So I just have gone to another direction where we were, what question we were discussing. Okay, so we did not find in this one, we did not find any peroxy linkage. Here also I did not find any peroxy linkage. So this actually what we are supposed to find, which of the following compound is or not having peroxy linkage. So this did not have any peroxy linkage. And this again, let me add it here. What do we mean by peroxy linkage? Peroxy linkage is something like this, where you have two oxygen joined, just like O2 2 negative, we say it as peroxide. So peroxy linkage is wherever you have this sort of a linkage or this sort of a bonding. So we did not find in first two. Now coming on to the next one, let us check in that one the salt of a calcium. So what exactly it is? So here again, three borons are being given. So I would just place three borons at the corner of a equilateral triangle type of a thing. Okay. And now what we are supposed to write is the oxygens. So I just have added these oxygens like this. Now here you have to do a bit of permutation combination, because when you break this anion, what do you end up getting here? You would get calcium 2 positive plus whole of this anion would have 2 negative charge. B3O4 OH3 would have 2 negative charge. So I just would want two negative charge onto it. So what I can do here is, and this oxygen which is being written here, this particular oxygen, this 4 oxygen also is showing the fact that these oxygen atoms are between the 3 boron atoms. So I can place this oxygen here. One way is this. Now still the covalency of this boron is not complete, and others are almost complete, but we are left with OH. So I just would place one OH here and one OH here and one OH here. On placing OH onto a boron which already has 3 bonds, so it would get a negative charge. Let me repeat once again, I may have gone a little fast. So I just have placed 3 boron atoms. These are being joined to each other through oxygen. This is what we did. And to get the 2 negative charge, I have brought one oxygen here. Now the covalency of this boron got completed. Now I still have to place 3 OH groups and 2 negative charge. So what I did is, I just have placed one OH here, one OH here and one OH here. By virtue of this, this particular boron would get one negative charge and this also would get one negative charge. So it is almost done with. Coming on to the next part, here also we did not find any peroxy linkage in this one also. Another style of question which may be asked in a single integer type of equation, that how many BOB bonds are there in this particular structure as well. So that you always have to keep it in mind. Similarly, let us go to this one. So now you have 2 boron atoms. So I have with me 2 boron atoms. Now you have 2 oxygens are 4. Now here I think we need to be little vigilant about. So I can place it here like peroxy. This also as peroxy, because I could categorically see that if I would break this out, I would get Na2 positive and the whole anion would get 2 negative charge. So I just would want to place 2 negative charge along with, and I still have 4 OH groups. So one OH group here, one OH group here, one OH group here, one OH group here. As a result of this would get a 1 negative charge, 1 negative charge, because around boron there are 4 bonds created. So this particular species do have a peroxy linkage. So we found here in this molecule has 2 peroxy linkages, and that means this would not be our answer to this question. So let me see into the other options. So this did not have any peroxy linkage. It do have peroxy linkage. So which of the following compound not having peroxy linkage? So these 3 ABC did not have peroxy linkage. These did not have peroxy, but this do have peroxy linkage. So this means our question to this question, our answer to this question would be ABC. ABC would be our answer to this particular question. So the question was interesting and important. Moving on to the next question, which again is a more than one choice, but it is a STEM type question where sequence of things are being asked to you. So in such questions, I always suggest my student not to see into the options first. First, make a flow chart hurriedly, and then try to figure out what are basically K, L, M, N, O. All of these compounds are to be identified in this. So first we do it ourselves, and then we'll see into the four options. Okay. So let me create a bit of flow chart here. So what they are saying, that there is a compound K. There is a compound K, and this compound is of sodium and boron. Sodium salt of some boron compound is being heated. So this is a very popular reaction. A glassy transparent bead is being formed, which contain two compounds L and M. Okay, so this is a very popular compound. I hope you got the idea that what exactly is K. And then this L is being treated with carbon dioxide. Okay, fair enough. Where it is, the compound L, when treated with carbon dioxide, it gave me back the K. Okay, and N, where it is, and N, K and N. Okay, K and N they gave. Whereas compound M, when hydrolyzed, gives O. Fair enough. And O on treatment with N, O is treated with N, that is this one, O is treated with N to give you back the K. Okay, so it is quite confusing and interesting. So here the examiner is checking that are you having the clear idea, because for sure the sodium salt of boron, which when heated, is suggesting me that he is talking about the borax, because borax bead test, very popular it is, borax bead test. So directly, indirectly, the examiner is identifying or trying to explore out of you that do you know all the reactions of borax. That is what the endeavor would be. Now let us do it carefully and try to figure it out, and then see into the options given to us. Here one more important thing is they are asking incorrect statement. This is also to be taken care of, which generally sometimes we do the question rightly, but we opt for the wrong options. Now, as regard to the borax, we already have done this borax bonding we already done in the previous question. So borax, when heated to almost above 500 degrees centigrade, it dissociates like this: sodium metaborate, along with you would get B2O3. So if this is your K, and this can be L and M, or this is L or M, this we have to identify. Now here I just would want to tell you that if I just write the bonding aspect of it, once again to you, this is what because this will 2Na positive plus B4O72 negative. Now here the point is, as a matter of fact, you always have to remember that at times this heating or most of the reactions can be visualized through the mechanistic viewpoint also. This entire big three-dimensional structure may dissociate in such a way that it gives you a beautiful viewpoint, that on heating you may say it like this: this bond goes here. Is it okay? If this bond goes here, this bond goes here, and if this goes here, this bond goes here. Okay, and if I do the other way around, if this bond would move here, or rather I shall say it like this with the orange marker: if this bond goes here, this goes here, and I just would place a negative charge onto this oxygen. And now the reverse way, if I will bring it here, this bond goes here. Wow, this goes here, this goes here, and this would come here. Beautiful. So what basically we found is, so writing from this corner, so this boron got a double bond, and here it would get a negative charge, fair enough. And the second part, so this is the orange part we got on one side, and other thing which we are generating here is, so oxygen boron, this is the double bond, or rather I should write it like this. This is the double bond which we got, and here also we got a double bond, and along with it what else you got is double bond boron and O negative. So this is the beauty of the thing. So this is the orange part which I am talking about, and this is the bluish part which I am talking about. Isn't it interesting? Okay, so this means what you actually end up getting is 2 moles of borate, metaborate ion. This is metaborate ion, 2 moles of metaborate ion along with B2O3. So what are these? If I just would ask you the common names of this is sodium metaborate, and this is called as boron trioxide, and at times this is also called as boron sesquioxide. Sesqui means that oxide which is having sort of, if I just would write its empirical form, 1:1.5. So when oxygen is present with the boron in such a way that it is having 1.5 oxygen to match the thing, so this is commonly called as sesqui. So this borax bead test, this particular compound, these two would appear as a transparent glassy bead which is used for the salt analysis, because if that bead is being touched with some copper salt or manganese salt, it would give you a characteristic color. So that we will take up in some other video. During I will play some questions on the salt analysis as well. Okay, now so we almost have identified K and L. So K is found and M is found. Now M is being hydrolyzed and L is being treated with carbon dioxide. So if I just would write now, we have already identified this one. This was M, which is on hydrolysis, gives you boric acid. Now this would again, a mechanistic viewpoint here also could be generated, which would be a little lengthy one, but you I just would give you a beautiful hint about it, and you try it at your place. So this is to be treated with water, so it would go like this. So as a consequence, what you end up getting here is, you would get boron, this would get a negative charge here, oxygen, boron, oxygen. So basically if I would mark it, so here you would get a positive charge. Now comes the intramolecular proton exchange, just like in the organic chemistry. So you end up getting OH here, OH on this side, O, B, O. Again you just would add water. I would do this in a speedier way now. So this goes, so intramolecular proton exchange would happen. This H positive goes here. Ultimately you end up getting, from here you would get BOH, BOH, O, B. So here also you would get OH, and here also you would get OH. Isn't it? Not very difficult. And similarly, if I would move further, just hold on. If I just would move further into the next slide, here I am. So if I just would write this BOB, OH, OH, and here also OH, OH. So again, if I just would add water into it, this would attack and this opens out, and once it opens out, what do I get here? So this would become OH, and on this entity you would get positive charge. Now comes the intramolecular proton exchange once again. So you end up getting 2 moles of boric acid here also. So basically you created how many boric acid molecules? Basically 1 water is added here, which generated these 2 boric acid. So in the exam, sometimes this sort of question is also asked. You may get this sort of a problem also. You they would say you that this compound is given to you OH twice O, and this is shown it like this, and this is being treated with water. So make it a point, you need, if you have the concept clarity, you would reach to a right answer. And similarly, one water molecule I have added here, one water molecule I added here, and one water molecule I added here. So 3 water molecules give me 2 moles of 2 moles of boric acid. So this is quite important. Now coming on to the reaction of that I think I missed. What was that? Sodium metaborate. Okay, just hold on. Let me write it once for you where we are. Oh shit, I did a mistake here. Just wait a minute. So where we were, we are now supposed to treat sodium metaborate with carbon dioxide. This is the another thing which we wanted to add here. So sodium metaborate, it is to be treated with carbon dioxide. So what do we get here? So the simplest viewpoint here is you would need to have 4 moles of this, and this will give you Na2B4O7 along with carbon dioxide and some moles of water. The hit and trial, after hit and trial method, you would get what I wrote, just hold on, you would get sodium carbonate here. This is what I was wanting to place it here. So where, let me make the flow once again. So this was borax, Na2B4O7, and this is sodium metaborate, and this had been your B2O3. This B2O3 has been converted to hydrolyzed, gives you boric acid, and carbon dioxide when treated with L, this gives you again borax. That is what I was writing, and along with it you get washing soda. Now boric acid, we are left with one reaction. Boric acid is to be treated with now washing soda, that is Na2CO3. Is it okay? So I was talking about this particular reaction. I was referring to this particular reaction. How does it get completed? So for that, here it is. So this is the one I was referring to. This is K and this was N. Now here again also, if you would want to go with the mechanistic viewpoint, you can create here. Let me try it if we could get this. So this is carbon dioxide, and this is to be treated with borate. This is the borate ion. Just like the organic chemistry you used to do, this attacks this goes here. So as a consequence, you would get carbon dioxide, and here you have negative oxygen, and this would change this into this. Now because you have to bring in 4, then only the stoichiometry and reaction got balanced. So I just would add one more here. So another borate comes, this attacks this one, this goes here. So as a consequence, what you would get here, you would get O negative, and this would become negative, and you happen to get here BOB bond. Is it okay? So we almost have reached to this point. Now further, if I would do so, either you just would add another mole here, B O negative double bond O. So just add here, this goes here. So as a consequence, what you would end up now, so you have this moiety with you, B, and if you would see, this is negative, this is negative, here you have oxygen, then B, this also has become negative, O, B double bond O. Now one thing you can do here is just bring this down and throw this out. So if you throw this out, what you would get here is double bond OB, this is O, B, this is O negative, O. Are you feeling that we are going towards the borax? And what came out is carbonate ion, CO3 2 negative. this, because this was also negative. So CO3, this anion came out of the system. This came out of the system. It got subtracted, and you are getting this. And we still have to place one more borate ion. We still have to add one more borate ion. So let me show you once again here what I was suggesting you. So this is what we got. Now again, if I would just add one more borate ion here, so O negative double bond O, this would attack this, this goes here. So what ultimately I end up getting here? So BO negative, and here it is being attached by this. This moiety comes here, and you happen to get negative O B double bond O. So we have almost reached the point. Now what I can do here is I just would write this particular part in this fashion, O negative. This would attack it. This opens out. So what do I get here is, I think you are with me, although the story has become little tricky and important. O, B, and this bond got joined here. And now ultimately what would happen? This would attack this one, and this would create a negative charge. And that is what we are looking for. So we happen to get BOB, BOB, and these are joined to each other. B, although I went a little fast, but you can figure it out yourself also. So this is the thing which we have obtained from the previous reaction. So what basically we did, first I attacked this, and the 3 moles of the 4 moles, one is this one, then comes this one, that is the second one, this is the third one, and ultimately at the this was the 4th one, and from here I went to this side and then to this side. So you can try it yourself. It is not so tough. So at times I have seen that if you would do the things like this, the mind tend to retain the things for a longer duration of time. And lastly, this is the last one where you have to treat the washing soda with boric acid. Now if you would figure it out that few minutes back we actually have created, on hydrolysis of this, we created the boric acid. Now if I would go the reverse way, I would get the same thing. So this is the thing which you always have to remember, that here you have 4 boron, so I just would place 4 here, and you end up getting the final product, and this would come out as 6. So almost we have done everything in regard to this particular question. And here also, if I do this particular reaction in a reverse way, you would get the same thing. Where we were, here it is. So if borax and washing soda are strongly heated back, you would lose out the carbon dioxide. So this also you always have to remember. So the point here is, what are the things which we wanted to know and where we have reached. So where is that flow chart? Okay, this is the flow chart. So Na2BO2 is the L, this is B2O3. So almost we have wrote everything, and now we have to figure it out what options they have given. So we need to identify the incorrect statement. So let me write it here, KLMNO. So K had been R, borax. L had been sodium metaborate. M had been B2O3. N had been, I think we happen to get washing soda. And is there any O? O had been what we have solved. L carbon dioxide, K, N. M on hydrolysis gives O. So I think I wrote the wrong thing. L when treated with carbon dioxide gives K and N. K and N. N is washing soda, and M on hydrolysis gives O. So this is boric acid. And O on treatment with N. O on treatment with N gives you the borax back. Okay, we almost have got the right things. So L is sodium metaborate. This line is correct, and K is borax, so this statement is correct. M can be said as boron 6 oxide and N is washing soda, so this also is correct. N is calaminite. No, N is not calaminite. Now, what is calaminite? That I'll let you know. So, this particular part is wrong. And O is borax. O is not borax. So, this and L is sodium. So, the half part is correct, half is wrong. So, these two are wrong statement. Now, the question is, what is basically calaminite? Calaminite is another ore of boron, where CaB6O11 and I think 5 water of molecules are there. So this is what you call it as a very popular compound of ore of borax, which we call it as calaminite. So here I am placing you one homework question for this. Do let me know how many BOB bonds are there in this compound. How many BOB bonds are there in this compound? Do write on to the comment box if you get time. So how many BOB bonds are there in this compound? One problem they can ask you like this. And second is, how many water of hydrations are there? How many water of hydration are there in this particular compound? How many water of hydration are there in calaminite? So these are the two questions which you can think about. Hope so you enjoyed today's session, and we shall be bringing few more important problem solving sessions for the upcoming IIT Advanced, which is supposed to be on 28th of August. So those who are preparing for this exam or for IIT preparation as a whole, these sessions you would find it very helpful, how to tackle the problem in the paper and how is it inorganic mechanisms can be also thought of. Thanks a lot. Have a nice day. Stay safe and take good care of yourself.